So in order to fill the electrons, first thing that we need to follow is that electrons are filled in increasing order of energy levels. So increasing order of energy levels means that the first electron, if one electron is available for hydrogen, it will go to 1s, and it will be filled in 1s. But for helium, it has two electrons. Two electrons can be accommodated in an orbital, or so that's why 1s can have two electrons, and there is no need for the other subshells and orbitals to be written. But when you go for lithium, then it has three electrons. So according to the energy level diagram, if we follow the energy level, so the lowest energy 1s will be filled first. 1s will be filled first, and then comes 1s will be filled first, then 2s will have one electron. 1s2 and 2s1, and the same thing will go on. So unless the lower energy orbital and subshell is not filled, we will not move on to the next one. So like for that case, if you see boron, so in boron, O levels में आप you write 2, 3, but in A levels you know that this has electron subshells, and we have to follow the subshells electronic configuration. So boron has 5 electrons. So 2 electrons will go in the first lowest energy subshell 1s2, then 2 will go to, then 2 electrons will go to the second 2s2, then third higher energy orbit subshell is 2p, and 2p will have only 1 electron. So boron has 1s2, 2s2, 2p, 1 electronic configuration. Carbon has 6 electrons. So according to that, 1s will have 2 electrons, then 2s will again have 2 electrons, and then 2p will have 2 electrons. And in this way, you keep on filling nitrogen till neon. Neon has 10 electrons, so 1s2, 2s2, and 2p6. The key for this label is, if you see 1s2 means 1 is the principal quantum number or shell number, s is the type of orbital or subshell, and then the number of electrons are written as power or superscript on sp or d. So you see in neon 1s2, so first principal quantum number has 1, you know that it has only s subshell and s orbital, so it can have 2 electrons. Then we move on to the second principal quantum number, and then we have 2s available. We will fill 2 electrons in it again. It is now filled. Now we still have 6 electrons left, so we will move on to the next subshell, which is 2b, and then we can fill 6 electrons in 2b. Because 2p has 3 orbitals, px, py, and pz. So 2 electrons in each orbital collectively give 6 electrons in 2p6. So that's why 2p6 is there. So s subshell is s orbital, and s orbital can have only 2 electrons. P subshell has 6 electrons because it has further 3 orbitals, px, py, and pz. So 2 multiplied by 3 will give you 6 electrons. Similarly, if you will go for D subshell has 5 orbitals. We have studied in the previous class. So 5 orbitals means 2 electrons in 5 orbitals can give you a maximum of 10 electrons in D subshell. So S can have only 2, P can have a maximum of 6, and D can have a maximum of 10. F can have a maximum of 14, but we will not be following F electronic configuration. We will not go to that level. So that's why you see neon has 2p6, but if you see in neon, there are total of 8 electrons in second principal quantum number, and you did the same in O levels, and we have studied that, revised that in A levels as well. If you see neon, if you write it in the old method, So you see it has 2 8. Neon has 2 8 electronic configuration. And according to the modern configuration in subshells and orbitals, 1s2, 2s2, and 2p6, it still has 8 electrons, total of 8 electrons, 6 plus 2, 8 in the second principal quantum number. So that's why we are still following the same rule. So, in order to fill electrons, we are following the increasing level of subshells. And remember that when we are filling electrons in P or D, P can have a maximum of 6 and D can have a maximum of 10 electrons. Until they are not filled, we will not move to the next subshell. So, till neon we have studied, remaining we will study later on. The other way of filling electronic configuration to represent electronic configuration is by electron in boxes or showing electron by arrows. So you will have to see in what way they demand you in paper. Sometimes they just want you to write electronic configuration as 1s2 and then remaining you have to write it. So then you will write it like this. For neon, you will write it 1s2 will be given and you have to complete it by 2s2 and 2p6. But in case of arrows, then you have to draw these boxes, and then the boxes will have electrons in the form of arrows, half-headed arrows, half-headed arrows. Please see that. So if for case of boron, we have a total of 5 electrons, so we know that it's 1s2, 2s2, and 2p1. But when we are writing it in the form of electrons in boxes or electrons as arrows, so 1s box will have 2 electrons, then 2s box will have 2 electrons, and 2p, we need to draw all the 2p subshell with 2px, 2py, and 2pz, and we will put 1 electron in 2px only. The more important thing is that we have learned in the previous lesson as well, that when two electrons come into the same orbital, they will have paired spin, they will have opposite spin to reduce the repulsion, because we know that electrons revolve around their axis. So you see in 1s, we have drawn two arrows, but they are half-headed and they are opposite. Same in case with 2s, 2, you have to draw two electrons, two arrows, but they have to be half-headed and in opposite. And then in 2p, we have only one electron. Then we also have studied that electrons prefer to go to different orbitals of the equal energy. As 2p subshell has 3 orbitals, but these 3 orbitals have equal energy, and this phenomenon is called degenerate orbitals. Degenerate orbitals means orbitals with equal energy. So this can be found in p subshell or d subshell, and then even in f subshell, which we do not require. So p subshell has different energy from s and d, but then p subshell has 3 orbitals and they have equal energy. They do not have different energy, and their orbitals px, py, and pz, we call them as degenerate orbitals. Degenerate orbitals are defined as the orbitals with equal energy. So they have equal energy, and when we have orbitals of equal energy available, then there is a rule for filling electrons, and that rule we have studied in previous lesson, that electrons prefer to go to different subshell, different orbitals, and have same spin, rather than to go to different to go to same orbital and have paired spin. This will provide them with greater stability. So you see that here we have 1s 2, 2s2, and then 2px has one electron, 2px has one electron, and 2py has one electron. So we do not have put two electrons in 2px, otherwise it will be very unstable and we will not follow the rule, and rule is based on stability. So in case of nitrogen, you see that we have 7 electrons. So 1s2, it has to be filled first because of the lowest energy. Then a higher energy orbit subshell or orbital is 2s. it has 2 electrons with paired spin, but we still have 3 electrons left for nitrogen, which we have to put in 2p. If you are writing if you are just writing, then you can write 2p3. But if you are drawing boxes and showing electrons as arrows, you have to show that 2p subshell has 2px, 2py, and 2pz. 3 boxes are there, and all 3 will receive 1 electron each with same spin. With same spin. Not ये नहीं करना कि एक को upward downward कर दें, एक को downward कर दें. With same spin. Okay. So electrons will go to the same to different orbitals of the same energy and prefer to have same spin rather than to have paired spin and go to the same orbital. Then comes oxygen. In oxygen, we do not have any capacity to send a fourth electron from 2p to 3d or 3s, but we cannot do that. So oxygen में हमारे पास we have 8 electrons, so 1s2, 2s2, so pair of electrons are in 1s and 2s, and then we still have 4 electrons which we have to put in 2p subshell. So first we will put 3 electrons separately, and then we will add the fourth electron in 2px, and then we have to pair it and put the spin opposite. तो आपने जब भी degenerate को fill करना है, then you have to place the single electrons first and then you start pairing. ठीक है, तो इससे आपकी गलती नहीं है. तो पहले आप 3 electrons fill करें. First you add 3 electrons separately in 3 different orbitals and have same spin, and then you start pairing. So in case of fluorine, you see that there are 2 pairs in 2px and 2py, and 2pz is still unpaired and it has 1 electron. In neon, then we have all electrons paired. 1s has pair of electron, 2s has a pair of electron, and 2p subshell has 3 pairs of electron, 2px, 2py, and 2pz. And you see this orbital, this subshell is completely filled. And as it is completely filled, they have a fully filled valence subshell, and that's why they are stable. So this is another way of representing the diagram to show the electronic configuration using electrons in boxes. But when you are using electrons in boxes and showing arrows, you have to follow these 2 rules. That one, electrons will go to different orbitals of the same energy and have same spin. ये ख्याल रखना है आपने. और फिर अगर 2 electrons are there in same orbital, then you have to have opposite spin. दोनों की same spin नहीं बनानी. ठीक है. और learn to draw half-headed arrows. Half-headed arrows are required to draw in these boxes. Then there is another way of writing electronic configuration. One is, you can say that as in boxes and arrows. Second is a simple way of writing it, simply 1s2, 2s2, and 2p6. And there is another way of writing electronic configuration which has a noble gas core, or just write it in a, you can say it is an abbreviated form or short form of the electronic configuration, or you can say it is electronic configuration using noble gas core. Core means electrons which are present inside inner shells. So in these cases, in such kind of electronic configuration, if you see for boron, it has 5 electrons and it has 1 electron in the core, and the outermost shell principal quantum number is 2. So you need to simplify. You will write helium, and for helium it is 2s2 and 2p1 is the outermost shell. So you don't need to write the inner shell electrons. So for boron, helium लिख लें और 1s2 लिख लें, so it doesn't save time. But when we go to sodium, it has 11 electrons and its complete electronic configuration is 1s2, 2s2, 2p6, and then 3s1. So in order to simplify, we can use a noble gas core. Nearest noble gas from sodium is neon, and neon has 10 electrons. So when you write neon in bar brackets, Ne, it means that you have occupied 10 electrons. And then there is only outermost shell or principal quantum number is 3s, and it has 1 electron. So instead of writing complete electronic configuration of 1s2, 2s2, 2p6, 3s1, we can write it just like neon 3s1. Magnesium is neon 3s2 because it has 12 electrons. Aluminum again has 13, so it has neon 3s2 and 3p1. In case of potassium, which has quite a big atomic number. So potassium, you know that it is K19, and K19 has 19 electrons. So its complete electronic configuration is 1s2, then 2s2, then 2p6, then 3s2, then 3p6, and we know that after 3p we have 4s, so it has 4s1. The complete electronic configuration is like this. So potassium 19 has electronic configuration of 1s2, 2s2, 2p6. If this makes 10 electrons, then 3s2, 3p6, 18 electrons. And then 4s has 1 electron because 4 has slightly lower energy than in 3d. तो 4s की एनर्जी थोड़ी सी 3d से कम होती है, इसलिए 4s पहले फिल होता है 3d से, so 4s1. If you go for principal quantum number or shell number, so you see in first shell it has 2 electrons, in second shell it has 8 electrons, in third shell it has 8 electrons, and then fourth shell it has 1 electron. तो ये पोटेशियम की complete electronic configuration है. If you are required to write it as the core, noble gas core, nearest noble gas core, so you do not write helium or uh, helium or like neon, but the closest, the nearest noble gas to potassium is argon. So you will write argon, argon in the bracket, and it means that you have filled 18 electrons in argon. You don't need to write 1s2, 2s2, 2p6, 3s2, and 3p6. You just need to write argon. The whole noble gas core is done. All the inner electrons are done. Now the outermost subshell is 4s, 4s, and it has 1 electron. So argon 4s1 is the abbreviated form of the electronic configuration of potassium 19. So it depends how they want us to write the electronic configuration. So it can be in the form of arrows and boxes, and it can be in the form of simplified form like argon, and nearest noble gas has to be used. Okay? Nearest noble gas. So for boron, nearest is helium, but for sodium it is neon. But for potassium, it's argon. So you need to write argon. Simple सा बात है जी कि you need to show the inner electrons. Outermost shell electrons जो हैं वो तो बनाने ही बनाने हैं. Inner shell electrons are shown as the noble gas configuration. तो जहाँ तक noble gas का है nearest का वो inner core आपके पास आ जाएगा और बाकी electrons आपने outermost shell के दिखाने हैं. These are few ways in which you will show the electronic configuration and how to write the electronic configuration. Now let's see some electronic configurations of the elements from first proton number 2, the 30th and onwards. So hydrogen is 1s1, helium is 1s2, then lithium is 1s2 हो जाता है तो फिर 2s1, then boron beryllium is 1s2 2s2, इसमें sp fill हो गया. बोरॉन में फिर आपके पास 5 इलेक्ट्रॉन्स, you have 5 electrons, you have to write 1s2 2s2 and then 2p1 आपके पास जो है वो आ जाएगा. Then comes nitrogen. So nitrogen has electronic configuration of 1s2 2s2 2p3, and one more rule is coming towards you. Nitrogen is quite stable and it has very high ionization energy हम आगे पढ़ेंगे compared to oxygen because it has half filled p orbital. It is a rule that half filled subshell half filled subshell is as stable as a fully filled subshell. So nitrogen has a half filled because P has 6 electrons and its half is 3, and all 3 electrons are in different orbitals and have same spin. That's why they are quite stable. They are just as stable as a fully filled subshell. Therefore, 2p3 is quite stable. But in case of oxygen, 1s2, 2s2, 2p4, you know the fourth electron comes into px, 2px and has a paired spin, the repulsion is greater and it is not that stable and it's not half filled anymore. So oxygen is not that stable as compared to nitrogen. Then fluorine is 2p5, neon is 2p6, and 2p6 means it has outermost shell completely filled. Its outermost subshell 2p6 is completely filled and it has no more capacity to add electrons. Then comes for sodium 3s1, then magnesium 3s2, then aluminium 3s2, 3p1, inner neon is filled. Silicon is 14, so 3s2, 3p2. Phosphorus is 3s2, 3p3, again half filled हो गया है, नाइट्रोजन के नीचे होता है phosphorus उसी ग्रुप में. Then sulfur 3s2, 3p4, chlorine is 3s2, 3p5, and argon is 3s2, 3p6. Again आपके outermost shell भी भर गया है 8 इलेक्ट्रॉन से और उसका outermost सब shell भी भर गया है. पोटाशियम हम अभी देख चुके हैं 3p6 के बाद 4s1, कैल्शियम में then 4s2, और स्कैंडियम जो है यहाँ ट्रांजिशन एलिमेंट ही आपको सामने लिखा नजर आ रहा है, ट्रांजिशन एलिमेंट विच है वेरिएबल वैलेंसीज. तो उसमें आप देखेंगे कि 4s2 के बाद 3d1 आता है. तो यहाँ पर वी हैव अ प्री फिलिंग एंड पोस्ट फिलिंग रूल. प्री फिलिंग एंड पोस्ट फिलिंग रूल मैं आपके सामने इधर लिख देता हूँ. प्री फिलिंग जो है, प्री फिलिंग रूल तो यूँ है कि आपने भी जैसे देखा था कि इलेक्ट्रॉन जो है is filled in 4s before 3d. ठीक है, electron is filled in 4s before 3d, but after filling 3d and 4s swap, 3d and 4s swap, and we will write it like this. As you see 3d जो है वो हम 4s के अंदर लिखते हैं तो ये स्वैप हो जाते हैं. इसका मतलब ये नहीं है कि आपने जो है 3D में 3 इलेक्ट्रॉन डालने थे वो तो फिर वो गलत हो जाएगी इलेक्ट्रॉनिक कॉन्फ़िगरेशन. इलेक्ट्रॉन 4s में ही पहले भरे हैं. आप देख रहे होंगे इन केस ऑफ स्कैंडियम 4s is completely filled. 4s is completely filled. Okay, 4s2 is there, and then remaining the 21st electron that is filled in 3d, but after filling you need to show it in a swapped form. इसलिए 4s थोड़ा बाहर लिख के फिर 3d अंदर लिख लिया करें और 3d में 1 आएगा क्योंकि टोटल इज 21. In titanium it is 4s2, 3d2. Vanadium is 4s2, 3d3, but हम उसको अंदर की तरफ लिख रहे हैं. Chromium is very special. Many times they have asked about chromium, and then again copper के बारे में पूछते हैं कि क्रोमियम की इलेक्ट्रॉनिक कॉन्फ़िगरेशन होनी तो ये चाहिए थी कि 4s में 2 इलेक्ट्रॉन और फिर 3d4. 4s2 3d4 is it's what we expect it should be electronic configuration, but it is not, because we have studied a rule that half filled subshells are as stable as fully filled. तो फिर 4s2 और 3d4 जब लगते हैं तो 4s ने 3d से they have a conversation. 3d asks 4s कि भाई brother please give me 1 electron. I need 1 electron to be half filled and become stable. And 4s talk to itself that if I give 1 electron to 3d, there is no change in my stability because my total electrons are 2 and its half is 1, so I will also be half filled and I will remain quite stable. So that's why 4s keeps 1 electron and sends 1 electron further to 3d to make it 3d5. क्रोमियम में बच्चे अक्सर उसी रूल के चलते चलते में they make a mistake that they write 4s2 3d4. That's wrong. Chromium is actually 4s1 3d5, and you need to write it in the swap form. So 3d54s1 is shown in the diagram. So 3d54s1 means that they both have both are 4s and 3d are half filled, and it gives quite an extra stability to chromium, and it can have less energy, higher ionization energy. Then comes for manganese. उसमें आपको you do not need to transfer electrons from 4s to 3d because 3d is 5 and 4s 2. Then comes from iron, it is 3d6 4s2. अब यहाँ पे half fill करने से कुछ नहीं होना. 4s से अगर एक electron you will transfer to 3d, it will become 3d7. So there will be no half filling. So there is no shifting of electrons required. Then comes cobalt. It is 3d7 and 4s2. Actually, we have filled 4s2 first and then 3d7. Nickel is 4s2, 3d8, and we write it 3d8 and 4s2. And inner shell argon is there. Copper has 29 electrons, so complete argon to 3p6 हो गया. Then we need to write 4s2 and 3d9. 4s2 and 3d9. But कॉपर में भी वैसे ही जैसे क्रोमियम में, the same way as in chromium, 4s shifts one electron into 3d. That gives 3d fully filled and fully stable, and 4s is half filled and it is also stable. So like chromium, copper maybe we have transferred electron from 4s to 3d and gives 3d10 4s1. So for copper, you do not write 4s2 3d9. You will write 4s2 or 4s1 3d10 and not 4s2 3d9. Then in case of zinc, it is 4s2 3d10, and then gallium has more electrons 31. So after filling 4s and 3d, आपके पास अगला जो एनर्जी लेवल आता है वो 4p है. Then you start filling 4p, 4p1, 4p2, 4p3. Bromine has 4s2, 4p5. Krypton, again another noble gas, so it has 4s2, 4p6, and 3d is there. तो अगर आप देखिए क्रिप्टॉन को, तो इसकी इलेक्ट्रॉनिक कॉन्फ़िगरेशन में आप यू विल सी इन द फर्स्ट शेल इट हैज 2 इलेक्ट्रॉन्स. In second shell, 2 plus 6, 8 electrons. In third shell, 2 plus 6 plus 3 b भी third shell का हिस्सा है, although कि वो 4s के बाद fill होता था. So total electron are 10 plus 6 plus 2 is 18 electrons in the third principal quantum number or third shell. And then the fourth shell has 8 electrons again. So you see, जो हमने रूल ओ लेवल से पढ़ा था कि आउटर मोस्ट शेल में अगर 8 इलेक्ट्रॉन हो तो वो स्टेबल होता है. और नोबल गैसेस कॉन्फ़िगरेशन में except helium, all the elements have 8 electrons. So again, you have seen that. Rubidium then comes in 4s1, 5s1 because it is in group 1, and strontium is in group 2, so it's 5s2. So you don't need to write electronic configuration any further. So we have just seen odd ones, and for that chromium is an odd one. This means we have written 3d5 and 4s1 because we have this rule that half filled is as filled as fully filled. So we can do that. So I'm stopping right now. We will continue this in the next classes.